Dear students, so today I am going to start new chapter matrices. What is meant by matrices? An arrangement of mn numbers written in m rows and n columns enclosed in rectangular brackets is called matrix of order m by n. Let's learn. In standard 11th we have studied the types of matrices and algebra of matrices means, namely, first is addition of matrices, second is subtraction of matrices, and third is multiplication of two matrices. The matrices are useful in almost every branch of science. Many problems in statistics are expressed in terms of matrices. So discuss in details is one by one of the following. Let's study. First condition is elementary transformation, and second is inverse of a matrix. There are two methods. First is elementary transformation method and second is adjoint method. And application of matrices. First condition is a solution of systems of linear equations. There are one method of inversion, and second method of reduction are deleted. Elementary transformation. Let's first understand the meaning of application of elementary transformation. The elementary transformation of a matrix are in 6 operations. There are 3 in rows and 3 of columns. They are as follow. First is interchange of any two row and any two columns. If we interchange the ith row and jth row of a matrix, then after this interchange the original matrix is transformed to a new matrix. This transformation is symbolically denoted by Ri interchange R2 or Ri interchange J. The similar transformation can be due to two columns, say Ck interchange Ci or Cky. For example, if matrix A is first row is a 1 2, second row is a 3 4, then R1 interchange R2 gives the new matrix. This is a 1 2 is a row first, 3 4 is a row second, gives the new matrix R1 interchange R2. First row is a 3 4 and second row is a 1 2, and C1 interchange C2. C1 means column first interchange column C2 gives the new matrix. Column first is a 1 3 and column second is a 2 4. New matrix is column first is a 2 4 and column second is a 1 3. Note that A not equal to 3 4 1 2 and 2 1 4 3, but we write A equivalent to 3 4 1 2 and matrix A equivalent to 2 1 4 3. The symbol equivalent is read as to equivalent to. And second condition is multiplication of the elements of any row or columns by a non-zero scalars. If k is a non-zero scalar and the row Ri is to be multiplied by constant k, then we multiply every element of capital Ri by the constant k, and symbolically the transformation is denoted by k into Ri, or Ri implies k into Ri. For example, if matrix A is 0, 2, 3, 4. This is the 2 by 2 order. This is the square matrix. Then R2 implies 4 into R2, means multiply R2 by 4 gives A is equivalent to first row as it is 0, 2. Second row is we multiply R2 by 4. 4 into 3, 12, and 4 into 4 is 16. A equivalent to 0, 2, 12, 16. Similarly, if any column of matrix is to be multiplied by a constant, then we multiply every element of a column by a constant. It is denoted by KCI, or KI implies K into CI. For example, if matrix A is 0, 2, 3, 4, then CI implies minus 3 into Ci gives A is equivalent to first row is 0, 2 as it is. We multiply first column as it is, 0, 2 as it is, minus 3 into Ci, minus 3 into minus 3 is a minus 9. Then C1 implies minus 3 into C1 gives A is equivalent to first column is 0, 3, multiply minus 3 into 0, 0, minus 3 into 3 minus 9, first column is 0 minus 9 and second column is 2, 4 as it is. Can you say that A is equivalent to A is equal to 0 to 12, 16, or A is equal to 0 to minus 9, 4. And third condition is adding the scalar multiplies of all the elements of any row or columns to corresponding elements of any other row or columns. If K is a non-zero scalar and K multiplies of element of Ri into Ci are to be added to the elements of Ri into Cj, then transformation is symbolically denoted by Rj implies Rj plus K into Ri. Cj implies Cj plus K into Ci. For example, if matrix A is a minus 1, 4, 2, 5, this is a 2 by 2 order, and K equal to 2, then Ri implies Ri plus 2 into R2 gives. Therefore, A is equivalent to minus 1 into, this is a 2 into 2, multiply 2 into R2, and this addition minus 1 into minus 1 plus 2 into 2, 4 plus 2 into 5. We multiply R2 is a 5, 2 into 5. Therefore, minus 1 plus 2 into 2, 4, minus 1 plus 4 is a 3, and 4 plus 2 into 5 is a 10, 4 plus 10 is a 14, first row is a 3, 14, and second row as it is 2, 15, that is a equivalent to 3, 14, 2, 5. This is the 2 by 2 matrix. We discuss the next condition. Exercise 2.1. Apply the given elementary transformation on each of the following matrices. First condition is if matrix A is 1, 0, minus 1, 3, this is a 2 by 2 order, then find R1 interchange R2. This is the first row, 1, 0 is the first row, and minus 1, 3 is the second row. This is the square matrix. Number of rows is equal to number of columns. What is the square matrix? Number of rows is equal to number of columns. Therefore, given matrix A is 1, 0, minus 1, 3. This is the row first. This is the R1. minus 1 3, this is a R2. Then find R1 interchange R2. R1 interchange R2. Therefore matrix A is R1 interchange R2 and R2 interchange R1. Means R2 interchange R1 and R1 interchange R2. Therefore firstly we write R2 interchange R1. R2 is a minus 1 3. Interchange R1 means minus 1 3. This is a R1. R1 interchange R2. R1 is a 1 0. Interchange R2. This is a 1 0. The actual value of R1 interchange R2 is a minus 1 3 1 0. Okay. Next condition is example second. Matrix B is if matrix B is 1 minus 1 1 minus 1 3 1 minus 1 3 2 5 4 2 5 4 R1 implies R1 minus R2. R1 minus R2. Therefore matrix B is a given. This is the two rows. This is the first row, this is the second row, and 3 columns 1 2 3. Given matrix B is a 1 minus 1 3. This is the first row. 2 5 4. This is the second row, and 3 columns 1 2 minus 1 5 and 3 4. There are 3 columns. Then find R1 implies R1 minus R2. Given matrix B is 1 minus 1 3 2 4 5. What is the order of this matrix? This matrix order is firstly we write rows and secondly we write column. This order is a 2 by 3. 2 rows and 3 columns. Therefore R1 implies R1 minus R2. We changes the first row only. R1 implies the effect of R1 minus R2. R2 as it is. We write this is the matrix B. No change the R2. Second row as it is. 2 5 2 5 4 as it is. R1 minus R2. 2 minus 1. Sorry. 1 minus 2. R1 is a 1, R2 is a 2. 1 minus 2 minus 1. R1 minus R2. Minus 1 minus 5. This addition is a minus 6. And R1 minus R2. 3 minus 4 minus 1. This is the value of R1 minus R2. This is the matrix B is a minus 1, minus 6, minus 1, 2, 5, 4 as it is. Okay. And third example is, we write the third example. Third example is if matrix A is 5 4 1 3. 5 4 1 3. This is the square matrix. If matrix A is a 5 4 1 3, C1 interchange C2. C1 interchange C2. Find C1 interchange C2, and matrix B is 3 1 4 5. 3 1 4 5. 3 1 4 5. Then R1 interchange R2. Then R1 interchange R2. then R1 interchange R2. First example is if matrix A is given 5, 4, 1, 3. This is the 2 rows and 2 columns. Find C1, interchange C2. And matrix B is given 3, 1, 4, 5. This is the 2 rows and 2 columns. Find R1 interchange R2. Solve this example. Given matrix A is a 5, 4, 1, 3. Given matrix A is a 5, 4, 1, 3. What is the C1 and C2? Column first is a 5, 1 and column second is a 4, 3. This is a C1 and this is a C2. Then find C1 interchange C2. C1 interchange C2. C1 is an interchange to C2 and C2 is an interchange to C1. Therefore, matrix A is C1 is a 5, 1 interchange to C2 and C2 is a 4, 3 interchange to C1. Therefore, C1 interchange C2, C2 interchange C1. We write firstly C2 interchange C1, 4, 3 in C1 position, and C1 interchange C2, C2 write C1 write C2 position 5, 1. This is the equation first. C1 interchange C2. This is the new matrix A is 4, 3, 5, 1. C1 interchange C2. Therefore, given matrix B is 3, 1, 4, 5. This is the first row, this is the second row. This is the R1 and this is the R2. This is the first row and this is the second row. Then find R1 interchange. Therefore, R1 interchange R2. R1 interchange R2 and R2 interchange R1. R1 interchange R2 and R2 interchange R1. Therefore, matrix B is this is R1 is a 3, 1 given and R2 is a 4, 5 given. R2 interchange R1. We write firstly R2 interchange R1. R2 is a position R1. R2 interchange R1 4, 5 in R1 position and R1 interchange R2 3, 1 R2 position. 3, 1 R2 position. 3, 1 R2 position. This is the equation second. R1 interchange R2. R1 is a 3, 1. We write second row and R2 interchange R1. We write first row. 4, 5 is the first row and 3, 1 is the second row. This is the equation second. From equation, we observe the equation first. New matrix A is a 4, 5, 3, 1. This is the equation first. We observe a new matrix of B is a 4, 5, 3, 1. This is the equation second. From equation, first and second. New matrix A is a 4, 1, 3, 1. This is the square matrix. This is a 2 row and 2 column. And B is, this is the square matrix. This is the 2 row and 2 columns. New matrix A and new matrix B are equal. Therefore, A is a 4, 5, 3, 1 and B is a 4, 5, 3, 1. Equation first and equation second are equal. Therefore, from equation first and second, therefore, new matrix A equal to B. Therefore, new matrix A equal to B. A is 4531 equal to B is 4531. Do you understand? Okay.